Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
So one of your biggest hurdles when you become a freelancer is to build your name, build your reputation, build your brand. And writing and having these things published was a big help for all that.
Hello and welcome to the Being an Engineer podcast. Today we're speaking with Erin McDermott, who, after years of, in her words, corporate engineer drudgery, abruptly quit her job and jumped headfirst into finding a way to make it on her own. 7 years later, Erin has built an optical engineering consultancy and grown a network of talented, independent hardware engineers, many of whom she coached to help find the tools and mindset needed to survive on their own. Erin, welcome to the podcast.
Thank you for having me, Erin. I'll be other Erin.
Yeah, we were just talking before starting the show that we have a couple of Erins here at Pipeline as well. And we just hired some people. I have to share this because it's funny. And so now we have a Larry, a Carrie, a Gary, and a Terry here at Pipeline. We have a Sean and a John, and we have two Mikes and two Erins and two Jasons. So apparently, if you want to work at Pipeline, your name either has to rhyme with someone who already is here or be the same as someone who was already here. Ridiculous. And so, speaking of the Erin and Erin, I mean, me, Erin, and Erin McDermott, Erin, I grew up in Hawaii, and there's like a very specific way to say my name, Erin, with the two A's versus generally the girl name Erin with an E. And that has been lost here as I've moved away from Hawaii. The accents are not quite the same, but people would call me Erin growing up, and then the E-R-I-N was Erin. So just a subtle difference, but one that I took great pride in growing up.
That's the first I've heard that. So maybe Hawaii's weird. I don't know. I don't think you're
Hawaii
really
is definitely
there.
Weird in a good way. Yeah. Yeah. Okay. Well, Erin, what made you, Erin, not Aaron, Erin, what made you decide to become an engineer?
I needed the money, Erin.
Yeah, that's a good answer right there.
So my family was pretty poor growing up. Both my parents were disabled, and we were always told, me and my brother as kids, that, Dad's gonna die early, so it's gonna be rough pretty soon. So my whole thought process in high school was always like, I have to find a way not just to make money to support me as a teenager, but to support a whole family as a teenager. And how do I do that? So first I was actually going to be an artist because my thought process was I need to do what I am best at, and that way I will succeed. And I'm like, well, I guess I'm better at art than most other people here. I could go into commercial art. And then I got a really bad grade on something, and I dropped the class immediately. I'm like, I'm not going to pay someone for 4 years to tell me stupid things about art. It's art. And at the same time, I was taking physics, and I really, really liked the physics, so I picked up pre-calc, where I used to have the art class, and then, I want to go into theoretical physics, but that doesn't pay the bills, Erin.
And was this all in high school still?
Yeah.
Wow. Yeah. What a load to carry in high school.
But, loads shape us, I guess, so that is probably why I am where I am today, whether that's good or bad.
Absolutely. Absolutely. I was talking with a close friend of mine a few weeks ago, and he's a little bit older than me, but has been very successful in life. And I asked him, things just seem to go well for him in life. He just succeeds everywhere he goes. And I said, what do you attribute that to? And he said, well, I was kind of on my own from a pretty young age, starting at, 17 or so. Financially speaking, I was on my own. I had to figure all this stuff out. So I think that you're 100% right that really does shape you and build some extremely valuable skills.
Yeah, it doesn't feel good at the time, but, looking back, those things are always what you attribute some of your successes to.
Sure. Yeah.
So to get through school, though, I didn't have enough money to pay for college on my own. So I had to wait a whole year, like delivering Chinese food, and I was working 80 hours a week and scooping custard for a whole year just to save up enough money to get to the first quarter of college. And that was Kettering University, which used to be General Motors Institute. And I chose that school because in Michigan, it was the only program actually in the world, it might still be, where you could do co-op, where you're actually earning like real money from your freshman year.
Really?
And it was 12 months out of the year you're at school or work. So you do 6 months of work, 6 months of school from your freshman year. And I'm like, that's the only way that I'm going to be able to afford this. So,
that's incredible that they have that program. How wonderful.
Yeah. And the classmates really spoiled me that I went to school with because, you know, they're people who are really motivated on their own to do stuff. Like, you don't go there for fun. This is not a party school. It was a dry campus, you know? So then, you know, going into the working world afterwards with people who didn't come from that really rigorous background was really interesting to see the difference in mentalities and work ethic and stuff between these different groups.
I bet. Yeah, you probably felt like half the people were slowing you down after that.
Sometimes.
All right. So you paid for school as you were going to school. Was it difficult to get into
I'm still
that
paying
program?
For school.
Okay. Well, was there a lot of competition? Because I mean, to me, that seems like a really great deal. You have to work a lot, but hey, you pay for school as you're going. That's great.
Well, at that time, it was 2000 is when I graduated high school. So the working world was really hard for engineers. It's not like it was today. And I knew a lot of people who went to that university that had to drop out because they couldn't find a co-op job. There was no one hiring. And that was one of the biggest hesitations for a lot of people at that time. That is not the case today. Companies are fighting for these students. I went back a couple years ago. I said, is there anything I could do to help these poor students out that can't find co-ops? They're like, we have no problem with that.
That's not a problem. And what kind of work did you do? I mean, as a freshman, you don't have much engineering experience yet. So what did you do?
It took me a while to get the co-op job. I think I was maybe a sophomore by that point, or maybe a junior, maybe a sophomore. But one of my professors was talking to Federal Mogul, which was on campus one day, and he actually got me the job because, you know, I studied applied physics. That was my core discipline. And the person he was talking to from Federal Mogul, which is an automotive manufacturer, if you're not familiar, that guy also was a physics doctorate. He's like, oh, well, I love physics students. And one of the problems, you know, that I was having was, what am I going to do with an applied physics student? And I'm like, I could do anything. You got electrical engineering, mechanical engineering, whatever. So I was also doing an applied optics concentration. So there are 3 different concentrations you could choose from: optics, acoustics, material science. I chose optics because I'm from Rochester, New York, which is the home of optical science. And there's a whole bunch of, or there was a lot of optics industry there. And I want to go back home and help my family eventually. That was the plan. So this job that they had was for laser process development. So not product development where you're making new products, but using technology on the manufacturing line. Kind of similar, I guess, to what you do, to make products more heat resistant, wear resistant, stronger, by adding new processes just here and there in the assembly line. So that was really cool to enter product development from a process development perspective. And I did that for 2.5 years, mostly with high-powered lasers, but also high-powered microwaves and really fun stuff.
That sounds like a lot of fun. Yeah. Well, eventually you decided to leave the corporate world and go out on your own as a freelancer. What motivated you to make that decision?
A lot of pain.
From the lasers? You got burned too many times? Cut off a few fingers?
There were some flames there. Well, I had several jobs after that co-op. I didn't end up working there after. I worked in industrial sensor development at Lloyd's Electronic, and then I went to Valeo Pennsylvania, which was Osram and Valeo, to do automotive headlamps and taillights and stuff like that design. And then I went to commercial lighting. But while I was at Valeo back in 2011, I wasn't able to pay the bills. So I still had all this debt, even though I had huge scholarships, which I negotiated with the university. Because I'm a girl, and just by having me there, we're going to change the ratio of men to women.
Good point. Yeah. Solid negotiation tactic.
Yeah. I still graduated with a lot of debt, and I was also affected by the recession. I got laid off in 2008, and it took me over 2 years to find another job. So I was deeply, deeply in debt. And when I finally got hired again, they knew that I was desperate, so I got paid peanuts. And I was really, really struggling financially. And I looked up the ladder when I was, at my second job out of college. And I looked at those people and I said, do I really want that job? Do I really want to be doing what they're doing? Like just a different cubicle or a different office in the same gray, building? And I said, nope. So I was considering, going to get an engineering management or MBA, master's, just because I need to make more money. I need to climb up some ladder. And I decided, no, forget that. I'm going to start my own company. And so in 2011, I started Spire Starter LLC, but I really didn't do anything with it until I left my next company I was at. So the next company I worked for, I was there for 3 years, still just playing around with things with my company on the side, but not really making any money with it. And then when I left, I took a sabbatical. I didn't have any job lined up. I'm just like, peace out. It was one of those times when I just couldn't take anymore. I was in Chicago. I was, commuting 3 hours total a day. Couldn't afford a car. So that was all public transportation in the polar vortex. And I have bad knees.
Oh my goodness.
It was bad. So one day I just was like, and we're done. And I went off to Ireland on sabbatical. And I was just like, I need to concentrate and be away from all my friends, all my family, like everyone, and just figure out a new company, a new way to make money. But I didn't think I was going to do engineering as a freelancer because I knew freelance engineers. And I would go to conferences where I was looking for a new, full-time job, and I would meet other consultants there. And they all had this like desperation in their eyes, Erin, of like, I can't find work. Help me. And other people would be like, that I'm friends with who are freelancers, would be like, I don't know how I'm going to put gifts under the tree for this Christmas for my kids. And like, there were no happy stories with engineering as a freelancer. So I was not even going to try that when I started. I was going to try anything else. I went back to art and started playing around with doing art and writing and making videos. Long story short, I guess I got kicked out of Ireland, went backpacking through Asia, got really sick.
Kicked out of Ireland? Let's not just gloss over that part. That sounds like there's a story there. All right,
they
I'll leave it up to you.
They are really protective of their whiskey.
Okay.
No, it was a weird thing with immigration. Like, I left and tried to come back, and they wouldn't give me a new stamp, so they officially didn't give me permission to land.
Got it. Okay.
So they're like, you got a week, you got to figure out where you're going, or we're going to put you in jail. We're going to come to your house and drag you off to jail. Yeah. So then I had liquidated like pretty much everything that I owned and only had like $12,000 left that I was like, I need to just live on that for 6 months to figure out this new business. So now I'd put all this money into this house in Ireland in the woods, and now it's gone, and now I have to figure out how to live with even less money. So the only place I could afford was Asia. So, I found a captain who needed crew in Malaysia, and I flew there, and then we went up to Thailand.
Holy cow.
It was pretty nuts, yeah.
This is one of the most amazing stories I've heard. Keep going, please. I'm fascinated by this. And then while I was over there, I'm like, I had this, there was this
vendor from the last company I worked for that they had some problems with their manufacturing, and I am intimately aware of those problems, and I have free time. Maybe I could go meet with them in Japan and see if I could, do some contracting that way. Yeah, that was a big fail. Do you know about Japanese culture at all?
A little, actually. I lived there for a bit.
Oh, wow. So it's hard being a chick and trying to start new business negotiations. And I also brought a translator with me he started talking to the guy on his own. I'm like, what are you saying? I didn't tell you to say anything. He was like, I'm just asking if he thinks it's legal what you're trying to do. Why would you ask that, dude? So that did not work out, clearly. And during all that time, I got very, very, very sick. Well, by the time I came back to the US, I could barely get out of bed. Showering was difficult every day. I was trying to apply to just contract positions because that was my fallback originally. All right, I'll spend 6 months. I believe I deserve that for myself. I'm going to at least give me that much of a chance. 6 months to just concentrate and find new work. If I can't do that, I'll just get a contract engineering job. So I'm applying to these jobs, and it's taking me 2 days just to write the cover letter because my brain is so messed up. And then I'd read it 2 days later and be like, that is not even grammatically correct.
No.
What is wrong with me? So my body was literally falling apart, and I'm I'd lose my hearing for a couple days, and then I'm slurring my speech, and then one of my legs doesn't work. It was crazy. And all the doctors are like, we don't understand Asian things, diseases and bugs and parasites that you might have encountered. So they're clueless. So at that point, I went to New York City just to try to get medical treatment from better hospitals than my hometown that had more equipment on site. And the only way that I could think to make money was, all right, I'm just gonna have to do sales. I wanted to do technical sales before I quit my last corporate job. But I was turned down for that because I didn't have sales experience, even though I was a sales engineer, which you're not really doing sales as a sales engineer, but they're like,
Right.
You don't have sales experience. So I was like, well, I'll go get my own. And I started working at different companies, just doing basically commission-only stuff. There's a mural painting company that had a whole bunch of, this collective of artists that I worked for a little bit. And then Bot Factory has these 3D printing, 3D printing, but for circuit boards. Really cool stuff. So I was doing that. And, I would just walk in and say, hey, you don't have to pay me unless I bring you money. And people are okay with that.
Yeah,
and
I'd say.
It was a lot easier, surprisingly, right? It's a lot easier to go in and just try to sell yourself as a freelancer than it is to try to get a traditional job and go through, first the online robot wall, and then there's the HR wall, and then there's the, then you finally get to the manager, maybe, who needs you. So it's a more direct line if you take on more risk and higher success rate of getting gigs. So I did that for a while, but it wasn't bringing in any money. It was, but barely enough to survive. And the sales VP of sales for one of the companies said, would $20 help you at this point? And I said, yes, it would. So he's like, you could do writing articles and making videos for this tech magazine. I know the editor. Would you like that? And I said, yes, please. So he introduced me to the editor of Solid Smack, Josh Mings. And I started writing for them. And I'm so glad that I was in a position where just $20, $40 or $100 was significant to me, because otherwise I wouldn't have ever done it. And writing for that magazine gave me so much, because I could go to different places, and even if I couldn't sell my services, I could still get in the door and be like, do you want some publicity?
Yeah.
And that was super helpful. And also, when you're coming from a corporate environment, you don't have a name. You know, like, I would try to go to conferences and my boss would be like, no, you can't go there. So I would pay for myself to go to these places when I would go to conferences. So one of your biggest hurdles when you become a freelancer is to build your name, build your reputation, build your brand. And writing and having these things published was a big help for all that.
That makes a lot of sense, and I can kind of relate. I know that, I mean, I've done a lot of sales myself, being forced into it, being the business owner, right? Yeah, back in the day, it was just me, so I wore all the hats. And it's hard to get people to listen to you and to respond to you. And one thing that I have learned, I mean, I've only been doing the podcast for coming up on 3 years now, but it is so much easier to get people to respond to you if your approach is not, hey, I'd like to sell you something. What do you think? It's hey, I've got this podcast. I think you'd be a great guest. You know, are you open to sharing some of your insight and experience with the engineering community? And people are much more willing to give in that way. So I hear you. Yeah.
Everybody likes publicity.
Yeah.
So while I was going to one of these conventions to help out one of my clients, I ran into Randall Chinnock from Optimum Technologies, and he was an optical engineer who had his own company, a very large company with lots of different disciplines underneath. He would do medical devices that specialized in optics. So I just saw his booth and I'm like, all right, I'm not interested in optical engineering. I don't want to do it anymore because it's not a path forward, but please tell me what you're working on because this looks really cool. And he keeps talking and he's like, I got this project that I don't really want. Are you sure you don't want to be an optical engineer anymore? And I said, absolutely not. He's like, a couple minutes later, are you sure you don't want, are you sure so I took the contract from him.
Okay. All right.
And I didn't have the software to do the work, and it wasn't a big enough contract to make it worth purchasing. Simulation software is normally what I would do for these contracts. So I contacted one of my buddies in Germany that I used to work with. One of the companies I work for, I spent like 8 months living in Germany as a corporate engineer. And he was one of the freelancers there. So I said, hey, you already got the software. Do you want this project? I'll just give it to you. And he's like, no, I'm not flying to Boston for this thing. So he says, you can go there and you can negotiate the deal and you can find out exactly what's wrong, because what they think is wrong is not what's actually wrong most of the time. And so, actually come up with a package of work and I'll do the work and we'll split things. So we did that. And then at the end of the year, I was looking at all the different activities that I was doing and just spreadsheet, like I'm not making decisions emotionally. I'm going to make decisions based on the numbers, and the numbers told me
classic
actually
engineer.
Optical engineering. So actually optical engineering was the most lucrative path forward. And I thought, maybe working in a network is that kind of trick to get around this problem that all these other freelancers were having, trying to do it completely on their own. Because how much work do you get, Erin, from referrals or other types of introductions, or just, I don't know, maybe you don't in your industry, but it's...
Oh, we get almost all of our work from referrals and repeat business. Yeah. Well, what a journey. Holy cow. That was awesome. Thank you for sharing all of that and being so vulnerable. So you found kind of the trick there, like working within a network of people as opposed to just trying to go it on your own. And is that how you got to where you are now, developing this network?
That's how I did it for several years. But then 2020 happened.
Yeah.
And so for me, the biggest way of getting clients besides referrals, which actually isn't huge for me, but it was significant, was the face-to-face, in-person networking that I was doing. So during that time, I was still writing for Solid Smack, and then I eventually also picked up a British tech magazine, Develop 3D. And I would go around the world interviewing people at makerspaces and startups and accelerators, and going to all these places, to feature people, but also it's getting my foot in the door to all these different companies. And that was hugely important for building my business. And I was doubling my revenue every year, and 2020 was going to be the year where I'm like, all right, I'll be able to finally breathe after this year. It's going to be great. But then COVID.
And then COVID happens. Oh my gosh, this is so painful for me just listening to this. I'm like, okay, yes, finally, Erin's she's going to make it. It's going to be a success. And then,
Exactly. Thank you for feeling my pain.
I feel it.
So also during that time, though, I had a couple of the subcontractors that I was working with. They weren't completely following my instructions, and that was causing a lot of problems. So I ended up, for one of the projects, I'm in the hole for, because I had to bring in another engineer just to verify what the first engineer did. And that person didn't do anything wrong, but the way that they were communicating with the client made it look really bad.
Okay.
And so that was one of the lessons I had to learn the really hard way. And I eventually went back to Randall Chinnock, who got me my first contract as a freelancer. And I consider him my mentor now, because he's been there for every pivotal moment of my independent career. And I said, what do you do, with these people that are under you and they're in contact with the clients? Like, how do you make sure that they're not saying something that's going to tank your business? He's like, yeah, Erin, you don't let them talk. He said he also had to learn the hard way. You think someone's really competent, but they don't understand, like, there's a bigger, like, business overall bird's eye view understanding of what's going on compared to just the technical nitty gritty understanding of a project, and the way you word things and the way you present things and the way you compare your work to something else needs this bigger understanding that a lot of engineers don't have. So he would vet engineers for a very long time before they were allowed to directly speak with the customer. So in 2020, I had two problems, right? So I was relying on this network of engineers that I was hoping were eventually going to send me work, but I was sending most of them work, and I wasn't making much money off of it. So it really wasn't worth it to me to be working with them in this way anymore. And then also, I lost my sales pipeline because I couldn't travel and go to all these conferences and meetups and visit places in person. So that's when I thought, all right, before I shut down my business, because I was very close to just shutting it down, I'm going to build a network of all these people that I have, but like put it online. And then if we have a representation of many, many different disciplines, it's not just optical engineers. You go here if you need an optical engineer. Well, that's only going to bring so many people. It's only if they remember that, oh, optical engineering, I need to go here. So I was trying to find a way to bring more people with more broad needs to one place, one website. So I asked a bunch of different freelancers, hey, do you want to like try to pool our network influence together in one place so we can get more clients? And that's how I built Odd Engineer. It still exists today. It's not exactly how it looked originally. Originally, it was like 1 hour paid consultations with a bunch of different disciplines. And so the thinking there was, if you needed electrical engineering or a surface, what is it called? Class A surface modeler, or injection mold expert, or illumination design, or imaging optics, or Bluetooth, or other IoT. Anything you need that's weird, just go there and you can find them by their niche specialty. And more granular than just electrical engineer, optical engineer, because normally you don't search for, I need random optical engineer, I need random electrical engineer. No, you want someone who's, built these devices to go on dolphins underwater so that they can hear symphonies, You want something much more specific than that. So that was actually one of the hardest parts of building this site where we would all be featured, was to help them market themselves in this way where clients are actually looking for specific words and nouns instead of just, yeah, I'm a great electrical engineer, I can do all the things, I'm a jack of all trades. No one wants the jack of all trades. They want someone who will help them with their specific problem, with their specific component, in a specific industry sometimes. Those are all specialties. So I ran that for 4 months just to see if it was possible, try to keep it as short as possible just to get feedback to see if it's worth investing more in. And like, it kind of worked, but it didn't meet the goals that I had set. I wanted an appointment for everyone. I think only 4 of us got one. So I shut it down. But then after that, I had inadvertently rebranded myself as the person who knew all these weird specialties of engineering for hardware. And so I'm getting all these calls like, yeah, can we have a call and go over my project and you can pick out certain engineers for me? I'm like, that's not a service that I offer, guys. So I brought the website back because I was also getting a lot of engineers who wanted to be featured. Just like you saw, with the podcast thing, everyone wants publicity. Free publicity. Sure. Yeah, I'll take that. So yeah, I brought it back, and I don't force people to have the paid consultation calendar thing anymore, but it is offered if you want to add that on. I used to take a cut of the consultations with the pilot, and now I don't. So you keep 100% of whatever you earn. You can use that calendar on your own personal website or your business website. And it's more just a directory to find really hard to find talent. And then also this year, I started up a bunch of meetups to help the people who were paid members of the site, to give them a little extra besides just like being featured on the website, so that they could actually interact with other freelance hardware engineers, because it's something that's really hard for us to do, right? As engineers, it's not one of our talents.
So what is your business model today then? It sounds like it's still evolving, but what are some of the core elements?
Well, Odd Engineer is just like a side thing, and it's more of a hobby, I guess.
Okay.
Although we did win a $175 million contract with NASA, which we might get some. Like, we don't get the whole thing, but it would be like a couple small projects within that big umbrella that I'll be applying to for the community to be able to do work for NASA.
Nice.
But primarily, like, I do my own optical engineering for usually startups that are well-funded. They're not like early stage. They've, made it past the first rounds of getting knocked down and they got some funding.
On the subject of optical engineering, what are some of the projects that you've worked on? Because I think a lot of us don't work with optical engineers very much, or if ever, right? And we don't fully understand, like, viscerally what it is that optical engineers do. So can you give us a couple of examples of projects that you've done in the past?
Yes. I mean, you just hit the nail on the head of one of my biggest problems with trying to promote my business, is that most people don't know what it is. They don't know what optical engineering is. They're like, oh, so you work on eyeglasses. No, it's not that, first of all. So optical engineering is very broad, actually. I mean, the laser process development, that would sort of fit into it. Technically, that's photonics, not optics, but it's the same type of nerd that you'll find at the same conventions. The bigger kind of split between different categories is imaging and non-imaging. And imaging is anything where you're creating an image. So the camera for your iPhone, that's an imaging optic. But the illumination, that is the flash on your iPhone, that's non-imaging. That's not creating an image. That's just,
but it's still part of optics.
Yes. Imaging is telescopes. Imaging is microscopes. Non-imaging is IR sensors that aren't creating an image. It's just getting like an on-off, yes, no, 0, 1 value. What else is there? Oh, indicator lights, like weird lit effects with RGB LEDs, that you see on electronic components. I do a lot of that stuff too. Light pipes and other like weird lit effects. It's a lot of fun. It's actually harder to do than other things, but usually there isn't a big enough budget to actually hire someone like me, so it's a little more rare that I get those. today.
I did a light pipe, I don't know, many years ago. And to this day, I still don't know if it worked correctly. I handed it off and kind of never heard anything back. So I'd love to hear some feedback on the way I designed this. And this was based on some feedback I had received from an optical engineer I knew. So it was the LED was placed basically right up against the beginning of the light pipe, the start of it, and all of the faces of the light pipe, except for where the light was emitted at the end, were highly polished. And then at the end, there was kind of a texture or a roughened surface finish. And I guess the light kind of refracts off of the polished exterior surfaces, so it doesn't leave the light pipe. And then at the end, because of that roughened finish, then it can actually exit, and that's where you see the light. Did I have the core foundation right?
Yes, and that is the hope. The problem lies with the gradient of the curve. If you're bending your light pipe, that can be a huge deal breaker.
Okay,
if that isn't correct, and the position that you have your LED. But yeah, basically you want a light pipe to have polished sides, and then the exterior surface that helps if it's roughened to help light come out. But I've also seen people take that basic understanding and then use a diffusive material. So something translucent, a white, foggy kind of plastic.
Yeah, okay.
And then if you have a lot of that diffusing material in there, usually it's titanium dioxide particles, then you don't have a light pipe anymore because it's, you're messing up the angles that you need to keep it inside the pipe when it hits the side. It's not the right angles anymore because as soon as it hits one of those particles of the white balls of titanium dioxide, it's scattered into like 100 different angles that aren't going to stay inside once it hits the edge.
Got it.
Yes, those are the basics, but there's lots of weird little intricacies that you have to be aware of.
Yeah. What are some of the tools that you use as an optical engineer, both like physical tools as well as software tools?
Yeah. I should also mention that like my biggest thing that I do is lighting development for machine vision, because usually that needs really highly controlled, high power lights that you can't find off the shelf. But to do that, if it's imaging or non-imaging, you're usually going to use simulation software. I like light tools because I can use that to build optical surfaces really easily.
Is that a software program, Light Tools?
Yes. Synopsys makes it. It's one of the it's not the most expensive one, but it's up there. But I love it, so I keep using it. It's my favorite thing that I've played with ever in my career. So when I worked at other companies, at least one of them had like their own software team that would build tools just for the optical engineers to build optical surfaces. And by that, I mean like the inside of a reflector or, optics, lens surfaces and structures and textures that you would build on. So lenses, reflectors, light pipes, all those things. If you're just trying to build that in CAD, you're not going to have tools that easily lend themselves to making those things. So I work at companies that had whole teams that would build tools just to use within like CATIA, or they'd have separate tools for building these surfaces. I don't have a whole team to make the custom proprietary tools for me. So I can hack a lot of stuff in Light Tools, and then I'll export that, and it doesn't look pretty, but if I'm interfacing with a really great mechanical engineer, they can clean it up and make it a very nice surface. So that's one of the reasons why I love that software. And that is for, there's sequential and non-sequential, and this is a non-sequential. So that just means it's shooting the light from the light source, and it bounces around anywhere that it wants to in the system, as it normally would. Sequential would be like ZMAX is for imaging for like cameras and stuff. And in that you say, okay, first it's going to hit this lens, and then it's going to hit this lens, and then it's going to hit this lens, and then this aperture, and then the target. And it's totally different software, totally different way of doing everything, different terminology. It's like a completely different world. So those are the main like software tools, is simulation software to trace millions, if not billions, arrays through CAD.
Wow.
And then capture that on different targets that you create. And that can be for like in automotive. If you're building a headlamp, you need to hit certain test points on like a wall 100 feet away. That's how they determine if it can be sold or not, if it's legal. And so you can do that in simulation software. Or if you need a certain amount of light on a target, if it's a machine vision thing and you're trying to light up your desk or, the assembly line, you can measure how much light you're going to get from different off-the-shelf optics or custom optics that you develop, or with different light sources. You can change how intense those light sources are being driven with how much power is going through them. So it also makes for a really great tool for root cause analysis. Because one thing I've learned is you just should always expect the first product you get from the factory to be not right if it's an optical system. There's so many different things that can go wrong. If the driver isn't correct, it looks like it's an optical problem. It's not, but it looks like one. If the lens comes out of the mold weird, that looks like it's an optical design problem, but it's a manufacturing problem. If it wasn't assembled perfectly square to where it needs to be, that can look like an optical design problem, but it's a manufacturing problem. If you have the wrong resistors in your circuit board, that can look like an optical design problem, but it's an electrical problem. But the cool thing is you can model all of those different variations in the software really quickly, and you can isolate them. So when you're trying to figure out, is this an optics problem, or is this someone else's fault? It makes it a lot easier to see. So you can, look at 100 test points and say, well, it's only this one that decreased by 50%. But if they all decrease by 50%, then that's not, something came out of the mold weird for this lens on this side. Right. It's an electrical problem, most likely.
So are most of the tools that you use as an optical engineer software-based and not so much hardware?
There are hardware things, but they wouldn't be things that I could keep in my office. So usually there's a gonio photometer for measuring luminaires, for measuring like lamps and stuff like that. And that'll be this big dinosaur-looking thing that takes up a gigantic room. And you hang the fixture from this contraption, and then a meter will travel all around this light to capture how much light is emitted at every angle. And so from that we can get a distribution pattern, and then I can pull that into my simulation software to check, is this thing that I simulated, that I built in software, did they actually build the thing that I asked for? We can confirm that way.
Sounds like an expensive tool.
It's very expensive. And then there's also a sphere just to get like total lumens and a very precise measurement of color, because color calibration, that's a really important thing for, depending on the industry, like if you're working in cinema. And that's just it's a sphere. It's what it sounds like. It's a gigantic, like 6 foot in diameter ball. It's like a golf ball, but it's 6 foot. And then you put the light inside this gigantic 6 foot golf ball. And the light shoots onto every surface that's painted white inside that golf ball. And then there's one little sensor that captures just one point. And that is an integration of all of those light rays that hit all inside.
What would you test in something like that?
Any sort of illumination to get the total amount of light.
Oh, I see. Okay.
Or the color to get a very precise, if you want to know if it's 3000 Kelvin or 6500 Kelvin.
Got it.
Because if you're just doing that with a gonio photometer where it's measuring at different angles, you're going to have one color at the bottom and another color at 20 degrees away and another color at, 90 degrees away.
So are there companies you can go to just like rent that equipment, or is it just a service that you pay someone to do because it's so expensive to buy the equipment if you're not using it, every day?
Yeah, I just let them do it.
Yeah, okay. It's just a service. You pay someone money and they do it.
I mean, if you're a manufacturer of luminaires, of lights, and that's your main thing, you might have one in-house. I worked at a couple companies that had this equipment, and I would run this equipment myself. But now I send my clients to different labs to get different testing done. And there are also handheld meters that people use. But I have never, ever, ever in my career seen an optical scientist or engineer be like, oh yeah, we'll just use this handheld meter to determine whatever amount of light at this and then make a decision off of that. They are more for like rule of thumb things. And lately I was comparing different meters and like one of them was like 40% error. So, you don't want to make decisions off those handheld meters. It is more expensive to go to these labs with these gigantic machines, but the accuracy is like, you can actually use one and the other one's complete garbage.
Yeah, garbage in, garbage out, right?
Yup.
Okay. All right. Well, let's see. Let me just do one more question for you, and then we'll wrap this up. What is a tool that doesn't exist, but if it did, would dramatically accelerate the speed with which you could develop new products? And feel free to stray beyond the currently known limits of physics, even if you like.
Well, if you include the first production part review as part of that development process, then one thing that I'm surprised doesn't exist yet is that it's hard to measure cavities of like a mold, say, for a lens that you're injection molding or really any surface in manufacturing, and then easily convert that into a CAD file. Because like usually they'll just export a bunch of different cloud floating points. And like, I can't use that in simulation. So it would be really awesome if it were more readily available, at least. Like, I can't believe that this doesn't exist. This must exist somewhere, but I have not been able to find it.
So you're talking about like taking a point cloud and turning it into a solid model?
Yeah.
Got it. Okay.
That's scanning, like a part or a mold.
Yeah, we actually do some reverse engineering here at Pipeline, some scanning and reverse engineering. Yeah. And so I know, something about this, and it's interesting because people assume that you just scan something and then all of a sudden you have this CAD file that you can use. Well, no, that is not the case.
No.
There's a translational step that is largely manual, but is facilitated by some semi-automated steps in the right software. We use something called DesignX that's pretty standard in the world of reverse engineering. But it's basically a CAD program that has some semi-automated tools for reverse engineering, and you import your cloud data into DesignX, and then you use these basically CAD tools to create your solid geometry, and you export a CAD model, and you can export it directly into SolidWorks is what we use. So I guess
but are you playing connect the dots then with this software?
It's not quite connect the dots. Right? There's some tools in there that semi-automate the process for you. But so it's definitely a lot better than like trying to, like you said, connect the dots, right? That would take forever and probably not be that accurate. But there is a tool to do that. DesignX is the tool, and it's stupid expensive. When we bought it, which was like 6 years ago, it was like $20,000, I think, just for this tool. So if you're not using it a lot, it does not make sense to buy it, but there is a way to get that cloud data into a nice clean CAD model.
So would you be open to be sending you work when this happens to use that tool?
To be clear, that was not an ad for like, send Pipeline. No, that wasn't the intent, but it could be. It could be. Certainly, yeah, we could talk about that. All right. Well, Erin, is there anything else that we didn't talk about that you think we should have?
Let's talk about places where people can learn more about optics. That was one of your great questions. So, in the field of non-imaging, Julius Mushevek is a pioneer, and he has a bunch of different resources available. He teaches classes in illumination design. He's hosting some through Synopsis in January. He also wrote a book with Henning Wren called Designing Illumination Optics. It's on spie.org. That's really important because even if you are an optical engineer, you've gone for schooling in optical science, you probably did not learn about illumination design. It is so different from what you typically learn in optical engineering. There aren't courses in it. There isn't a degree program for illumination design. You have to learn it on your own and in the workplace. So those are amazing resources. And I actually asked Julius, I said, there's got to be some programs now. Surely it's been, decades that this has become a profession. He's like, nope, I'm writing a book. And that book is out now. So people can go get that.
Designing illumination optics, you said, right?
Yes.
Okay, I'll try and find it and put a link in the show notes.
Cool. And then community.eleoptics.com is a forum that's just optical engineers and optical scientists. So you don't have to be one to ask them a question. I've sent students there who wanted to learn more about optical engineering and optical science as a career. And the people there were really helpful in giving them feedback. So that's another great place to go. Also, I make TikToks about optics and engineering. So @SpireStarter is the name for that. And then we're hosting, I don't know when your podcast is going to come out, but there will be on December 15th, 2022, we'll have a meetup for a bunch of freelance engineers to just come introduce themselves, to get to know each other. I'd love for you to be there and talk about all the different things that you're doing with your companies and ventures. There's also going to be a forum that we're launching for people to reach out to each other without needing me to facilitate that.
Cool. So where can we learn more about this meetup and, when it's happening and how to attend and all that stuff?
You can go to oddengineer.com. There's an article posted there, and you can sign up through meetup.com. Odd Engineer has a meetup group.
Okay. Excellent. Great. Well, Erin, this has been really wonderful. Thank you so much for sharing all this and taking us through. Man, what a journey that you have been through. Talk about resilience. I am so impressed with you and what you've been able to accomplish through all that. So thank you so much for being on the show.
Oh, yeah. And then if anyone wants to contact me, they can go to spirestarter.com.
Thank you for adding that. Yeah. Perfect. Spirestarter.com.
Thank you so much.
I'm Erin Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.